Good morning students. Today's topic of discussion is hemoglobin, competition number 6.12, and subtopic is thalassemia, which is the last topic of this hemoglobin. The name thalassemia is derived from Greek word meaning thalas, which means sea. Now these Greeks have identified this disease which is present in a people who resides around the Mediterranean Sea, and hence the name thalassemia was given. Thalassemia may be defined as normal globin chains in abnormal proportions. All of us know that hemoglobin A is made up of alpha globin chain and beta globin chains. Normally the synthesis of alpha globin chain and beta globin chain is equal. Therefore the ratio is equal to 1. But in thalassemia this proportion is disturbed. There are two main types of thalassemia, alpha thalassemia and beta thalassemia. One more thalassemia is also there, which is called as delta beta thalassemia or hemoglobin leper. So beta thalassemia is more common than alpha thalassemia. In beta thalassemia, it is characterized by decrease or absence of beta chain synthesis. Alpha chain synthesis occurs, but beta chain synthesis is decreased or absent. Due to this, for compensation of this loss, gamma chain or delta chain synthesis is increased. Beta thalassemia are phenotypically described as beta plus and beta 0. Beta plus means where beta chain synthesis is decreased due to defect in post-transcriptional processing of mRNA. Beta 0 means complete absence of beta chain synthesis, and this may be due to mutation in the gene due to substitution of one of the nucleotide. In homozygous state means when both the alleles of beta chain synthesis are mutated or abnormal, then the clinical manifestations are severe and hence called as thalassemia major. And this homozygous state is characterized by severe anemia, hypersplenism, hepatosplenomegaly, hair on end appearance on X-ray due to expansion of bone marrow in the skull bones. This is the diagnostic sign of this disease. Heterozygous condition. In heterozygous condition means one of the allele is normal, another allele is abnormal. So 50% beta chain synthesis is occurring properly, and due to mutation in only one allele, the beta chain synthesis is decreased. The clinical signs and symptoms are minimum in this case, and they are called as thalassemia minor. After completing alpha thalassemia, beta thalassemia, now come to alpha thalassemia. They may result from different types of gene deletions. Alpha thalassemia is rare because number one, alpha chain synthesis is coded by two pair of genes. That means 4 alleles are responsible for alpha globin synthesis. Now presence of 2 pairs of alpha genes for synthesis of alpha chain, hence deletion of single gene or single allele or a pair of allele in the chromosome does not have much effect on alpha chain production. Alpha chain deficiency is incompatible with life. In homozygous state means when all the alleles are abnormal, the clinical manifestations are severe and hence called as thalassemia major. Heterozygous condition means when one or two of the alleles are normal and remaining 2 are mutated or abnormal. So the clinical signs and symptoms are minimal and they are called as thalassemia minor, just like beta thalassemia major and beta thalassemia minor. Clinical manifestations of thalassemia are here. You can see nucleated RBCs in the peripheral circulation. Normally the RBCs, which mature RBCs, does not have nucleus, but here in thalassemia premature RBCs enter into the circulation. There is hypochromic microcytic anemia. When you observe under microscope, the normal color of RBC is reddish. That color becomes faint and hence it is called as hypochromic. Microcytic means the size of RBC is also decreased. The color of RBC is faint because of presence of less hemoglobin inside the RBCs, and they are also of small size, hence it is called as hypochromic microcytic anemia. Now we can also observe inclusion bodies in the RBCs in thalassemia. Now these inclusion bodies means there is synthesis of defect in the synthesis of one chain, but other chain is synthesized in normal proportion. So that unaffected chain get aggregate and precipitate in the cell, because unaffected globin chain is synthesized in normal proportion and it does not have complementary chain. It cannot form hemoglobin molecule. So such extra globin chains get precipitate and seen as a inclusion bodies inside the RBCs. These inclusion bodies lead to damage and destruction to the red blood cells. Sometimes beta thalassemia is also associated with hemoglobin S. Now how do you manage thalassemias? Repeated blood transfusion is the available treatment, but this may lead to iron overload. When you are giving blood contain hemoglobin contain iron. So due to repeated blood infusion, the iron get deposited in the blood body, and this iron mainly damage the liver, leading to liver cirrhosis. Now splenectomy may lessen the anemia. All of us know spleen is the major organ where RBCs are destroyed. Abnormal shape of RBCs are destroyed. If you remove the spleen, then these abnormal RBCs are not destroyed in the spleen, and hence anemia is decreased. Bone marrow transplantation is a successful treatment and tried in few cases. After completing alpha thalassemia, beta thalassemia, I have told you one more thalassemia. It is called as hemoglobin leper. In this case, it is composed of 2 alpha chains and 2 delta beta chimeric chains. Normal hemoglobin is made up of 2 alpha chain and 2 beta chain. Here the alpha chains are normal, but instead of beta chain there are 2 delta beta chimeric chains. Now what is delta beta chimeric chain? Now delta beta chain is abnormal chain. It is a long chain. On N terminal it has delta chain, and at C terminal it has beta chain. Means beta chain and delta chain combines to form delta beta chimeric chains. Such thalassemia or such hemoglobin is called as hemoglobin leper, and this occurs due to non-homologous crossing over of chromosome in the cell. So this is about thalassemias. Thank you very much.